Okay, so objectives 77 and 78. One of them is substitution, the other one is elimination. Okay, so write this down. So it's y equals x minus 5. Y equals when we get done with today's notes, and you're assigned the rest, you can either choose to finish working on the rest, or if you still have some Alex you need to chip away at, I suggest you do that. So at 3:55 today, I'm not going to put them in the grade book at 3:55, but at 3:55 I'm going to print the reports off. So tomorrow morning, then I can start with equipment. But 3:55 is cut off. You can't add any more after that. I mean, you can, but it won't count for this section. Okay, ready? Yeah, what?
So at the end, like when we get to 494, will that be out of?
That'll be your end of course assessment.
Oh, okay.
Is what that's going to be. So it's a little bit different than the actual test. Okay, so this first one here, this would be substitution. So you use substitution and elimination are just two different methods to get the same answer. So sometimes one person chooses the other method because it's just the easiest for them to do. Okay, but I'm going to show you both ways. So usually you use substitution when there's a variable by itself. Okay, and in this case we have both of the equations have the variable by itself. So I want to move the smaller one just because it's less to have to distribute. Okay, so the way that this one, I'm looking at this one right here. So the way this one reads is y is 2x. So if y is that, then that means I can replace in the other equation the y with this, because y is that. Okay, so I'm going to rewrite that top equation with 2x, because y is 2x. Okay, and then I write the rest of the equation. So now I can actually solve this equation because now it's one variable versus two variables. Okay, so to get the x's to one side, what am I going to do? Subtract my x, subtract my x. So now I have x equals a negative 5. I've already solved one of them. Okay, so now you just choose which one you want to plug this x in, because now x is a negative 5. So you can plug it into this one or you can plug it into this one. It doesn't matter because it has to work in both of them. Okay, I always pick the smaller one just because there's less for you to have to add, subtract, multiply. Okay. So if x is a negative 5, then I would replace that x with a negative 5. Well, what is happening between 2 and x? Times. So 2 times a negative 5 would make that y equal to what? Negative 2. Okay, so now I have my 2 answers. You'll probably see on the Kia when you do it, they'll have their answers written as coordinates, so the x being first and the y being second. You don't have to do that, but that's probably how they'll have their answers. You can if you want to, okay? But there's an x answer and a y answer. Okay, so on a test or lesson quizzes, if you're like, did I do that right? It has to work in both equations. Okay, so we kind of use this equation the whole time, that second one. So if I just look at that top one and I plug those numbers into there, my y is a negative 10, right? And my x was a negative 5, and then I have minus 5. Does this left side equal the right side? What? Yes, because negative 5 and negative 5, right? The side's the same, so you add. Okay, so left side equals the right side. So you're going to make it right. All right, so let's try it again. 71. So x plus 2y equals a negative 8. And then y equals 2x plus 1. Okay, so we need one of the equations to have a variable by itself. And the last one, we had both of them had it. Okay, so this one, the second equation is the one that has it. Okay, so y is this. So if y is that, then that means I can plug in for y this to replace it. Okay, so I'm going to rewrite that top equation. So now I have x plus 2, and it's 2 times y. Well, now y is now the 2x plus 1. So by replacing that, all you're doing is getting one variable versus having two variables like the other equations. Okay, so now we just need to solve for x. So we're going to distribute. Okay, so I have x plus what?
2.
4x. Okay, and then I distribute to that one, so then that one's going to be 2. Okay, combining our like terms are on the same side, so we don't do the opposite, right? So 4x plus 1x is going to give me 5x. Okay, now I start doing the opposite because I have to move things to the other side. Okay, so I subtract 2, right, to get rid of it, and what I do to one side, I've got to do the other side. So now I have 5x equals negative 10. Okay, divide by 5, divide by 5, so my x is equal to a negative 2. Okay, so now it has to work in both equations. It doesn't matter which one you want to plug it into. I'm going to choose the bottom one just because then I would have to isolate and move things to the other side. So where the x is at, x is a negative 2. That means I would plug it into right there. So 2 times a negative 2 would make it a negative 4. So now I have a negative 4 plus 1, which means my y would be what? Negative 3. Okay, so if I was like, I don't know if I did that right, remember you can plug it into the other equation. Okay, so if I plugged in x there, that makes that a negative 2, right? And my y is a negative 3. Well, 2 times a negative 3 makes it a negative 6. Does my left side equal my right side? Yeah, negative 2 and a negative 6 gives me a negative 8.
Wait, you get the 1?
Yeah.
How'd I get the y?
Just the negative 3.
The negative 3. I just plug these back in. Or are you talking how did I get the
How do you get the negative 3 again?
Okay, so you see where I got the x, right?
Yes.
Okay, so now you can choose, because x is that, you can plug it in for this x or this x. It doesn't matter, because that's the old word in both equations, okay? I chose to plug it into this one just because then the y is already by itself, okay? So if I plug in a negative 2 here, 2 times a negative 2 is a negative 4, and a negative 4 plus 1, okay, gave me a negative 3. You could have plugged it into the top one, but then you would have had to move a variable to the other side. That's why I chose that second one. Okay, because it has to work in both, so it doesn't matter which one you plug it into. Okay, next one. 75. So this is similar to our last one, except it doesn't have a y by itself, it has an x by itself. So now we're going to replace the x. So x minus 2y equals a negative 14. And then x equals a negative 9 plus what? Okay, so we're looking for one variable to be by itself, right, to do the substitution method. Okay, so x is a negative 9 plus y. Okay, so that means I can replace in the other equation what variable? X, because x is this now. So I'm going to replace the x with that. So now it's a negative 9 plus y, and then I just write the rest of my equation because I just replaced the x. The x is no longer there. Good? So far? It's the same as the last one, just different variable. Okay, so now we combine our like terms. So I have a positive 1 and a negative 2, so that'd be a negative 1, right? And then I've got the negative 9 equals negative 14. Okay, so then I add 9, so now I have a negative 1y equals a negative 5. Okay, my y is not by itself, so it's just going to switch that negative 5 to a what? Positive 5, because negative divided by negative. Okay, so I have my y actually first. Okay, again, you choose which one is the easiest to plug into. If you plugged into there, right, into that top one, you go a negative 2 times 5, but then you have to get the x by itself, so you'd move it over to the other side. Personally, I think this one would be easier, okay? So if I put the 5 there, a negative 9 plus 5 makes what? Negative 4. So your x is negative. which you would get that if you started with that first one, because you'd have a negative 10, right? But when you move it to the other side, it'd become a positive 10, and a negative 14 and a positive 10 is negative 4. So it works in both. Kind of remember this? Okay. Because you would have done it last year as well, too. Okay, I want you to try this one. And then we'll go on to the elimination. It's not looking rude. Okay, how we do? Even if you just have one of them.
113. Negative 113.
I got 1 3.
I think we should. I think
You got one.
I got
1 for your y or 1 for your x? Okay. So we know, okay. So did everybody at least get 1? For the y? Okay. So when you plug this into this spot, you would have had 3, 8 minus 5y minus 4y equals 5. So distributing that would give us 24 minus 15y minus 4y equals 5. Okay, then those two together give you a negative 19y, right? We're good so far?
Yeah.
I just see some people right. Okay, so then you move the 24 over to the other side, so subtract 24 from 5 would give you, what? Negative 19. So you have a negative 19y equals a negative 19, right? So a negative divided by a negative would make it a positive. And that's your y, okay? Again, you can plug into this one or this one. I'm choosing the one that I always knew, which is usually the one that I Okay, so if I'm plugging a 1 in here, it's a negative 5 times 1, which is a negative 5, right? So 8 minus 5 is what? 3. Okay. So if you had a negative 1 here, because that's what you had, right?
Yeah.
That would have changed that to a positive, which means you added, and that's how you got the 18. So. Good? Okay, we're going on to elimination now. Okay, so this is number 82. Okay, so we have 2x minus 2y equals a negative 12. And then 3x plus 2y equals a negative 3. You don't have to write lined up. Okay, that's just for me. You can write it if you want to. Okay, so the key thing on these is notice that we don't have a variable by itself. Okay, so this is where you would use elimination. Okay, and what I mean by lined up is the x's need to be with the x's, the y's need to be with the y's, the equal sign needs to be in the same spot, and then the whole numbers. Okay, that's what we're talking about lined up. Okay, so elimination, what you need is one of the variables to have the same number, and then one needs to be a positive, one needs to be a negative. Do you see that anywhere? 2, right, for the y? Okay, so that means this one's already set up for us. We don't have to change things to get them to be the same number, and one's positive, one's negative. Okay, so this has already been eliminated then. Because really what we're doing is just like an addition subtraction problem. Okay, I have a positive 2 and a negative 2, so that means there's no y's left. So now I just have the x's. Okay, so I have a positive 2x and a positive 3x, which gives me a positive 5x. And then a negative, what? 15. Okay, so now I can solve for x. So I would divide by 5, divide by 5, so that means my x is a negative 3. Okay, so just like the last one, you just choose, because it has to work in both equations, because you're using the equations together to solve, okay? So you just choose which one. I usually pick the number that's where the x is at that is smaller, okay? Just because I don't want to have to work with bigger numbers, not that that one's that much bigger. Okay, so I'm going to plug it to that one. Okay, so the x is a -3. So I'd go 2 times -3, which would make it a -6. Okay, so now I'm solving for y, so I'd move this 6 to the other side, which would change it from a negative to a positive. Okay, which gets rid of that. So now I have a -2y equals a -6. Negative divided by a negative is going to change it to a positive 1. 3. Okay, so in my mind, I'm thinking, never trust that. I don't know if I did it right. I plugged it into that top one, so you could always check the bottom. Okay, so 3 times -3 would make that a -9. And then 2 times my y, well, 2 times 3 would make it 6. Okay, does that equal my right side? Yeah, so then I know I did it right. Okay, because I had to have worked in both the equations. So that's just a way to check it. You don't have to do that. You good? Okay, let's try this again. Your favorite. Fractions, yay!
So like I was cool with it. And
Now I just messed it up with you. There won't be too many of these. And I already know what half of you will do anyways. I'll just mark them wrong and skip over them.
Probably.
Forever. Not that I've ever seen that before. Okay, number 74, you have x over 3 plus y over 3 equals 1/3. And then on the bottom, we've got x over 4 minus y over 2 equals a -7 over 4. Okay, we do not like working with fractions, right? So let's get rid of the fractions so then they look like all the other problems that we have. So don't look at both of them, just look at one equation at a time. Okay, so we're not going to look at this bottom one. Okay, we're just looking at the top one. What is the common denominator in those three fractions? 3. Right. Genius. See, you're retaining something. Okay, so I'm going to put a 3 on the outside because I want to get rid of the denominators. Because what I'm doing is I'm dividing my denominator into that number that's on the outside, right? So really, they just cross cancel each other. Okay, and it would just leave that numerator, which is x. What's the next one? Y. I don't know. Okay, what's the last one? Negative. Okay, so it's really going 3 goes into 3 1 time, 1 times x is 1x. 3 goes into 3 1 times that is y. 3 goes into 3 1 time, 1 times a -1 is -1. So now I got rid of the fraction. Okay. What is our common denominator for this next one? 4. So I'm going to put a 4 on the outside. Okay, so my first one's just going to be what? X. This one not as easy as the other ones. I'm going 2 goes into 4 twice. So it's really 2 that's been distributed to what's left. Okay, so that'd be a -2y. And then the last one's easy. That's just going to be what? -7. Okay, questions up to that point, because now we have an equation that looks like the last one that we did, similar to it anyways. Good? Okay, so we need, and it doesn't matter which one, because we have to solve for both of them. We need one of the variables to have the same number in front of it, but one of them needs to be a positive, one of them needs to be a negative. Okay, which one do you want to work with? The x or the y? Because it doesn't matter, we have to solve for both. X. Okay, so if you chose the x, they already have the same number in front of them, which is what? 1. But I need a positive and a negative. So you just choose one of them that we need to change to a negative. Doesn't matter which one. I'm going to change this bottom equation. Okay, so when I'm doing that, I can't just change just the x. It has to be the whole thing. So that means I'm distributing a negative through to all of it, which just switches the signs of them really. Okay, so now I have a negative x. What's that? Right. Plus 2y. Right. Okay. your paper, I'm just crossing this off because we just said nice stuff. I don't show you that anymore because we just rewrote it. Okay? Well, what happens to the x's? They cross each other out. They're eliminated. Okay? How many y's do I have? 3. Negative 1 and a positive 7. 6. Okay? Solving for y. Divide by 3, so y would be 2. Okay? Now, we don't want to plug back into our original equations, right? Because those are fractions. We don't want to work with them. So just work with, it could be any of the ones that you have. Okay, I already crossed out that middle one. So it's either the top one or the bottom one. So where the y is at, I would probably plug it into the red equation. Okay, because otherwise you have to times and do stuff like that. Okay, so where the y is at, I'm replacing this with the 2. Okay, so this is now x plus 2 equals a negative 1. How do I solve for x? Move the 2 over, so it changes to a negative 2, right? So x is really negative 3. So your x is negative 3 and your y is 2. Good. Okay. This last one I'm doing with you, and then you're going to try one. So on number 77, it's 4x equals 5y minus 6, and then 4y equals 5x plus 12. Okay, are they lined up? No. X's aren't lined up with X's. Okay, the equal sign is, and the whole number is, and the X's need to be, or Y's need to be flipped around, okay? It doesn't matter which one, okay? I'm going to leave the top, actually, I'm going to leave this one alone, okay? I'm going to rewrite this one. So I want the Y to be on the other side. So if I'm rewriting this one and I want the Y to the other side, what's going to change with that 5Y? Right. Okay, so I'm going to leave this one, and then I'm going to have a negative 5Y. Okay, same thing with the x, I need to move it to the other side, so it's going to change to a negative 4x. But I'm not moving that one, because it's already lined up. Okay, so this stays the same. Okay, now they're lined up. Y's with y's, the equals lined up, the x's are lined up, and the whole numbers are lined up. Okay, do I have any that are the same number and positive, negative? None of them, right? Okay, what one do you want to work with first? Because it doesn't matter, we have to solve for both. The x or the y. Okay, so the y's, we want them to be the same number, and one needs to be positive, negative. Well, we already have the positive, negative thing, right? Okay, so don't look at this one, because this was the one I rewrote. Okay, so he wants to get rid of the y. So what could 4 and 5 both go into? What? 20. Okay, so that means I would need to multiply this by what to make it 20? 5. And you can't just do it to that one. It has to be the whole equation. Okay? So if I distributed that, it's going to give me 20y, 25x, and that'd be 60. Good. Okay. So same thing here. Now this one, I want it to be 20. So that means I would need to multiply it by 4. Okay, so that gives me a negative 20y, and then what? Negative 16x, negative, close, what? 27. Okay, what did I eliminate? The y's, right? So now I have 0 there. I've got to have something on that spot, so you got to put a 0 there. Typically, we've been crossing it off because there's already been something left side, right side. Okay. 16 from 25. 9. 9x. So that means I need to get the x back up. So that 36 needs to go to the other side, which will change it from a positive to a negative. So it's really 9 going into a negative 36, which would make it negative what? What? 4. I'm scared. Negative. This will probably be the longest one. Okay, so now you choose. Now, I would not choose the ones that we just rewrote because those are big numbers, right? I would go back to one of my originals where the numbers are small, okay? So here in my original, that was the smallest x. I had 5, right? This one has a 4, so I'm actually going to plug it back into that one, okay? So where the x is a negative 4, it's 4 times a negative 4, which would make it a negative 16. Okay, so then I would move the 6 over to the other side, which changes it to a positive 6. So that would be a negative 10. So 5 into a negative 10 gives me okay, so that, to me, that's the larger one than the fraction one. To me, the fraction one's not that bad. Okay, ready to try it? Yes, you are. Okay, here we go. And then we're done.